The example that you can see here is taken from problem set 1-2 in your pre-calculus with trigonometry book. Now this problem here actually is for problems 5 to 18. I've selected number 12 as the first example. For this number 12 here, it's a linear function defined by f of x is equal to 3x plus 6 with the domain. We have a domain of our domain is in between 5 and -5. For letter A, plot the graph using a window set to show the entire graph. When possible, sketch the result. Letter B, give the y-intercept and any x-intercepts and location of any vertical asymptotes. And for letter C, give the range. So I have prepared here the Cartesian coordinate system as usual. Okay, let's move this in a better position. Okay, and let's have our grids now. Okay, why is this one moving also? Oops. Okay. Okay, we have with the x and y axis here, and I already made some grid sum scales here. Okay, now I'm going to write the numbers. The domain is from -5 to 5. That's from -5, -4, -5, -4, -3, -2, -1, 1, 2, 3, 4, 5. These values mark our domain. Now I'm going to label corresponding y-axis numbers. So 1, 2, 3, 4, 5. Of course, you can choose any scales for y. In this case, I'm using symmetric, values. So I have from -5 to 5 for the x and -5 to 5 for y values. Now our function here is f of x is equal to 3x plus 6. Let's draw a table. Okay, define it at some points. Okay, but first we have to make a table containing all the domain, all of the domain, and also the corresponding y values. So we have, this is our x values, the set of our domain, and this would be for the y values, or the set of our range. Okay, let's write the domain is from -5, -4, -3, -2, -1. Let's extend the table. So we're going to extend the table. Okay, and let's make horizontal lines here and vertical lines. Okay, let's draw a vertical line here. And Let's erase this x here and replace it with let's write it here. Okay. Now we have negative 1, 0, 1, 2, 3, 4, 5. Now we're going to get the values for your y. If x is negative 5, just replace this x with negative 5. F of x is equal to 3 times negative 5 plus 6, that's negative 15 plus 6, that's negative 9. So I have negative 9 here. Now if your x is equal to negative 4, that's negative 12 plus 6, so that's negative 6. If it's negative 3, if x is negative 3, you have negative 9 plus 3 or plus 6, that's negative 3. So if you observe, your range is decreasing by a number of, a common difference of 3. So probably this would be 0. If negative 2, that's 0. If negative 1, that would be 3, 6, 9, 12, 15, 18, and 21. Okay. I have to erase this one so that we could have a space for graphing. And also I'm going to change my labels here. I'm supposed to erase only the numbers. So we have here, okay, I'm erasing the numbers and replacing it with the value which is inside the range interval. So how am I going to do that? I'm going to change my scales, my scaling for only for the y-axis, okay, and let's say a difference of 3. So I'm going to write down numbers which are in difference of 3. So this is 3, 6, 9, 12, 15, and so on and so forth. So this one is negative 3, negative 6, negative 9, negative 12, negative 15, and so on and so forth. Now let's add something here so that we can still add 18 here. And now we are going to plot the points. For x is equal to negative 9, if x is equal to negative 5, our y is equal to negative 9. So that would be, okay, let's use this one, this grid. So we have here, okay, we have this one. So we have this, and let's plot them. Okay, so negative 5, negative 9, so it's here. Okay, if it's negative 4, it's negative 6, so it's here. If it's negative 3, it's negative 3, so it's here. If it's negative 2, it's 0, so it's here. If it's negative 1, it's 3, so it's here. If it's 0, it is 6. If it's 1, it's 9. If it's 2, it is 12. If it's 3, it's 15. If it's 4, it's 18. And although we don't have a number here for the y value of 21, we could still figure out the pattern. We have a pattern, okay? And that would definitely bring you into a linear graph, or a graph that is, let me extend that for a while. Okay, a line that is the function 3x plus 6. So if you notice, let's take this grid here. Okay, now we have a perfect line here. Okay, we have a perfect line here defined by the x values with the domain -5 to 5, and our range is, what is our range here? Our range would be this part. This is our range. The set of values of y is our range. So let us write that in a more numerical way. Okay, with letter with the term y, with the letter y. Okay, so our domain is already given. So this is letter A, so thick. Okay, this is, so we get the answer now to letter A. We have sketched the result, and we know that our result is a line. We could observe that it is a line, okay, by connecting all of the points. Now for the letter B, give the y-intercept and any x-intercepts and location of any vertical asymptote. So let's begin with the y-intercept. Do we have a y-intercept here? Remember, y-intercept is when your x is equal to 0, or when one of the points crosses the y-axis. So in this case, we have found something. We have found that point, and it's 0.06. So our y-intercept is 0.6. Now how about our x-intercept? Do we have more than one x-intercept here? Our x-intercept is only looking at the given graph in this sketch. Our x-intercept is when y is equal to 0, or when one of the points crosses the x-axis. And in this case, we find that point here. That's our x-intercept right there when y is equal to 0, and that's -2, 0. That is our x-intercept. We only have one x-intercept and only one y-intercept. Now, how about any vertical asymptote? Now remember, this is a line. Okay, a line extends. A line extends in both directions. Okay, a line extends in both directions. It has no limits. It does not approach any number, any value on the x and y axis. It just goes to eternity until it is given certain domain. Now our domain here is -5 to 5. So basically our graph would be from here to here, and this one will it will determine line segment, which is still part of a line. Okay, so this one. Okay, and this is our graph, our actual graph for the given domain -5 to 5. So do we have a vertical asymptote here? Obviously None. So our answer for this question is no vertical asymptote. Give the range. What is our range? Our range is from, this is our range, from this point to this point. This is our range. Okay, this is our range here, this one. So what is the value, or what are the values in that range? Our range is equal to y in between the value from -5 for y. For x equals to -5, the value of y is equal to -9. And for x is equal to 5, the value is equal to 21. So this is our range. This is our range here. Okay, so now we have completely solved the problem.